Hello everyone. So next we are going to discuss about the model 5. So 8051 interrupts and interfacing applications. So first of all we are going to see what all the contents. So these are the contents within the model 5. We have 8051 interrupts and 8051 assembly level programming to generate external interrupts using a switch. Then we have some C programs, 8051 C program to generate square wave on a port pin using a timer interrupt. Then we have interfacing 8051 for ADC, that is 0804. Then for DAC LCD, then we are going to interface for the step up motor, and then 80 we are going to write the 8051 assembly level program. So we are going to see one by one. So first, 8051 interrupts. So we know what you mean by the interrupt in the sense. So interrupt in the sense it is an external event which is happening. So as it is given here, an interrupt is an external or internal event that interrupts the microcontroller to inform it the device that it needs a service. So usually interrupts in the sense what will happen is, so there is an event which will occur. It may be externally or it is maybe through the program, and it will inform to the microcontroller that it wants some service and it has to be given for it. So the next thing is the program which is associated with the interrupt is called interrupt service routine or the interrupt handle. So whatever the interrupt we are talking about, so the related to that interrupt we have certain programs written, so that programs will be there in a interrupt service routine. So next is about polling. So there is one more we have, that is in case of microcontroller we have called a polling. So what is this polling in the sense? The microcontroller continuously monitor the status of the given device. So in case of the polling, what will happen is, so microcontroller is going to observe if any interrupts are going to come to it. So this is called as a polling. So in this case, if microcontroller has to individually access the external devices or the external events to check whether they need any services. Then when the condition met, it performs the service. After that it moves to the monitor the next device until everyone is serviced. So here in this case what will happen is, it is going to check each of the device, and it is going to give the service for it. So until and unless all the services are all the services are given, so it is going to check for all the events. So example is, you can see jump not bit TF target. So in this case, like, until and unless there is a bit high, so it will be there there will be low bit from the TF flag, it will be there in a loop. Okay, so this is how we can write an instruction for this. So next, interrupts go through the following steps. So what will be the different steps you would get for these interrupts? So as you can see, it finishes the instruction, it is executing and saves the address of the next instruction on the program counter on the stack. So here in this case what will happen? So first of all, whenever it gets the interrupt, it is going to halt, or it is going to pause the current execution, and it is going to get the new address, and that is what it is given, like it finished the instruction, it is executing and save the address of the next instruction program counter on the stack, and whatever the next instruction is there which is on the program counter, that will be dumped on the stack. Then it will be loaded with a new address, that is, it is also the current saves the current status of the interrupt internally. So if any status are there, that if the PSW contains, that program status or contents are available, so all those things are loaded on the stack memory. Then it jumps to the fixed location in memory called the interrupt vector table that holds the address of the ISR. Again, whatever the program it is interrupting to the main program or to the microcontroller, it is having its own service routine written, so that all the service routine in the sense, it is the execution program for the interrupt already which is written. So service routines addresses are available in the interrupt vector table. So we are calling it as an IVT. So IVT holds all the addresses of the interrupt service routine. Then the microcontroller gets the address of the ISR from the interrupt vector table and jumps to it. So microcontroller has to jump to the ISR routine, and it has to execute the ISR. So then it is going to take the address of the ISR from the IVT, then it is going to jump to the ISR. Then upon executing the RET instruction, the microcontroller returns to the place where it was interrupted. So as we know, in case of the call, we have called we have RET instruction. It is called as a return instruction. So to come out of from the subroutine to your main program. So similarly, in case of your this one, in case of your interrupt, we have RET instruction return. So whenever this RET instruction executed in case of your sub what you can say interrupts, so your control is going to be transferred from this your sub interrupt program to your main program, or you can say the ISR to the main program. So this is how it is going to be executed. So next thing is 6 interrupts are there. So we are going to see one by one. So first one is reset or power of reset. So this is the first interrupt where we are going to have the one power up, so it is going to reset. Then there are two interrupts are at the side of the timers, that is timer 0 and timer 1. So these are two. Then two interrupts are aside of the hardware interrupts, that is at the P3.2 and P3.3. okay, so P3.2 and P3.2 are nothing but, so these are the external interrupts like INT0 and INT1. So these are the two external interrupts we will be getting. Then serial communication has single interrupt that belongs to both receiver and transmitter. So for the we know like in case of the serial communication, we need to have communication from receive and transfer what you can say interrupt. Then next is, so here we can see the interrupt vector table. So like here reset and its hex value on the RAM, or you can say the hex address. So reset is 00, so pin number is 9. Then external hardware INT0, it's a 003. Then timer 0, it is 00B. And external hardware it is 013. Timer 1 is 01 001B, and serial com it is for 023. And similarly pin number like reset we have on 9, external hardware we have on 12, and external hardware INT is 1 at the 13. So this is how we have the interrupt vector table arranged for the interrupts. So similarly here we can see a piece of code written. So as you start from the OR0H, then L jump main, so we have taken the address at the 30H. So you can see ORG 30H, in the sense we are skipping out all these addresses right from 00 to 23. We are skipping out all the addresses and directly we are starting from the 30H. okay, so that is what it is written, like from on the ROM location we are skipping the interrupt vector table, that is 00 to 23 addresses. These already pre-written interrupts are available, and we are skipping all those, and we are directly jumping to the piece of code written on from the location 30H. okay, so next thing is about handling the interrupts. So when you reset, upon reset all the interrupts are disabled. So when you just reset the button, then you are going to like disable all the interrupts externally, meaning that none of the interrupts will be responding to your microcontroller. So similarly we can enable or disable the interrupts using the software also, right? So we have something called interrupt enable register IE. So that is responsible for enabling or disabling the interrupts. So using this one we are going to enable or disable in case of your software. So next thing is about, so here we can see like interrupt enable register we have. So these are the bits which are going to make your interrupts enable or disable. So here we have EA bit. So this EA bit is going to, when it is high, it is going to enable all other bits. okay, so this is disable all the interrupts or enable all the interrupts. So EA enable all must be set to 1 in order to for rest all the registers to take effect. okay, so once it make high, then only they are going to work. okay, EA, then this bit is not like designed or it is implemented. Then ET2, so here enables or disable timer 2 overflow or capture interrupt. So this is designed for the timer 2, this is designed for the timer 1, this is designed for the external interrupt 1, and this is designed for the external interrupt 0, and this is designed for the timer 0. like this to enable or disable the different interrupts whatever we have. So all these bits are present. So how we are going to access them, it is based upon IE.7, IE.6, IE.4, 5.4, like this we are going to access them. Enable or disable all the serial port interrupts from this pin, like yes. So this pin is going to enable or disable the serial port interrupts, right? So this is how about the interrupt enable register. So next thing is it is about how to access the interrupts, or how to have the interrupts on the microcontroller. So there are some steps given here. So bit D7 of the IE register must be set to high, allow the rest of the register to take effect. So as I told previously also, so from this one, so here we can see until and unless you make this high, so all they are they are in they are not going to work. So this has to be high, then only all these bits are going to work. Okay, so bit T7 of the IE register must be set to high to allow the rest of the register to effect. And the value of EA, if AA is 1, interrupts are enabled and will be responded to if their corresponding bits in I are high. If EA is 0, no interrupt will be responded. So that is what, if EA is 1, then all the other bits or whichever the interrupts we are getting, that will be responded, otherwise they will not be responded. So next thing is about, here we have an example. So to see how we are going to enable the disable the interrupts by software. So you can see here, show the instruction to enable. First one is enable the serial interrupt, timer 0 interrupt, external in hardware interrupt. So first thing we are going to see, so they ask you to enable all the serial interrupts, then timer 0 interrupt and external hardware interrupt. So you can see here, so first thing what we need to do is we need to set you need to send this value, this kind of the value you can send, or another ways you can use this set B instruction, right? So set B IE.7. so IE.7 in the sense we know, like this bit, this is the first bit, this one bit. So this bit is high in the sense we can operate all these other bits, right? So this one bit has to be made high, then as it is given serial interrupt, it has to be made high, then and timer 0 has to be enabled, then external hardware interrupt has to be enabled. So these things are done. Then second case, they have to disable the timer 0 interrupt. So they ask you to disable the timer 0. So how we have to do, clear I1. So once you clear I1 in the sense it is a timer interrupt, timer 0 interrupt. Okay, then show how to how to disable all the interrupts. So how to disable all the interrupts, so if you want, just make this bit low, then it is going to disable all other interrupts. So this is how this is going to be executed. So next is about here we have is about the timer flag. It is raised when the timer rolls over. So whenever the timer rolls over, or it completes its execution, then it is going to be raised. So this is going to work into both the condition, that is in case of polling also and in case of the interrupts also. But in case of the polling, what will happen is we have to wait until the TF is raised. So continuously there will be observation, so and it is going to be seen when the TF is going to be made high. So there will be, like in case of the polling, the microcontroller is not allowed to do some other task, and it has to keep on watching the TF flag, so that it will be raised and it can be it can do anything else. So whereas in case of interrupts, what we have is we have IE register, like in case of the IE register, it is going to set or reset the bits, and based upon that TF is going to be raised, and it is going to execute the ISR, and it is going to perform the ISR routines it is going to perform. So until and unless the IE register is been set, it can do some other task. So this is how it can save the time in case of the interrupt interrupts, and it can do some other task. So this is how it's going to be performed. So there are some other things we are going to discuss in next videos. Thank you.